All right, so you should be on Schoology. There's a link to a review quizzes that's going to cover everything we've covered this month in summer school, and that's what I'm going to be reviewing right now. So let me refresh my screen. All right, so if you're still working on it, that's fine. You can keep working on it. I'm going to go over some of the questions. I'm checking right now to see which questions we need the most help on. All right. So, to start off, number question one was probably one of our better ones. Most people got it right. All right, so Mendeleev arranged the elements in the periodic table according to increasing mass and pattern repeating of chemical properties. As the elements were discovered, there are a few elements that not fit the pattern of Mendeleev, but today the elements in the periodic table have been arranged according to their atomic number. Okay, 60% of us got it right. That's pretty good. In this question, you can kind of weed out the beginning part because it's just kind of a little bit of a story. And the real information you need to today is this part right here. So is the end. So today, the pattern of the elements is based on the periodic table and is the atomic number. The atomic number also tells us the number of protons and the number of total electrons, not valence electrons, but just total electrons. Step number two. Which is the best example of heat being transferred by radiation? So remember, the three types of heat transfer are conduction, convection, and radiation. Conduction is transfer by touch. Convection is transfer of heat through a fluid like air or water. And then radiation is the transfer of heat without physical particles, so by waves. All right, so A is the correct answer because a bench placed near a fire, if you sit near a fire, you can feel the heat coming off the fire. That's getting to you through heat waves. All right, now we get way more into that, and we normally wouldn't this regular school year. But all the other answers here are warm air rising. Air is the fluid. So when warm air rises and cold air falls, that's convection. Warm air moving, typo, from the top of the bottom of the pot of the stove, that's convection. And then conduction is this metal spoon getting warm in a cup of tea. Because it's actually touching the water. Radiation is A. All right, which is the example of not matter. All right, so remember, matter is anything that has energy and takes up space. All right, so has mass and takes up space. Sunglasses have a mass. They take up space. So does a beach towel. Sunlight does not. Water has mass and takes up space. All right, so everything about it has mass, which means, it takes up a space and it has a weight. You can measure the weight of it. You can do that through all of these things except sunlight. All right, if I said get 5 grams of sunlight, you have no idea what that looks like. All right, you can measure out 5 grams of each of the other substances. Things like electricity, like thoughts, the internet, those are not matter because they are not, they don't have mass and they don't take up physical space. So that's the definition of matter. So sunlight is not matter. All right, which mostly influences the properties of an element. All right, it's atomic number. The atomic number tells us how many protons there are. If you change one proton, you change the element completely. Okay, so for example, oxygen, the stuff we breathe, has 8 protons in it. All right, if you add 1 proton to oxygen, you get fluorine. That's no good. Fluorine's very bad for you. It would kill you. If you took away 1 and you went down to 7, you would have nitrogen. Right? You can't breathe nitrogen air. So changing the proton changes the element's properties, which is basically how it behaves and how it acts. That's the most important part. You can change if you change the electrons. You can. Oops, too much. If you change the electrons, you change the bondability, kind of how it bonds. You can change the neutrons. Will change the mass, but it'll change some things about it. But the biggest influence is the protons, which is the atomic number. All right, which statement is true about alkali metals? All right, they are located on the leftmost column of the periodic table. Half of us got that right. That's good. All right. They are very reactive, so B is false. They're called metals. Metals aren't a gas, so that one's pretty obvious. And then they form ions with a -1 charge. This one's almost true. They form ions with a +1 charge, not a -1 charge. This one, if you just read it quickly, could have tricked you up. All right, so leftmost column in the periodic table, alkali metals. All right, so which 2 atoms are the same element? All right, most of us got this one right. Great job. All right, so you got to look at the picture on this one. All right, so all right, let me zoom in a lot. All right, so which 2 atoms are the same number of protons? So you got to look for ones with the same number of protons, and you can see that X and Z both have the same number of protons, so they're the same element. Atoms can have the same number of protons and different numbers of neutrons. All right. All right, scientists isolated 4 different isotopes. Which property is different among these isotopes? All right, so in an isotope, this is in the notes, is an element that has the same number of protons as another element, but a different number of neutrons. The mass number is made up of the protons plus the neutrons. So, for example, carbon that has 6 protons normally has 6 neutrons, which would have its mass of 12. So 6 plus 6 would be 12. However, there exists another form of carbon that has 8 neutrons. So its mass is 14. 6 plus 8 is 14. So the number of neutrons will make it a different isotope, and the isotopes behave slightly differently. So the mass number is the change in protons and neutrons. The energy level, which was the other most common answer here, that would be the number of electrons. All right, and isotopes have the same number of electrons. All right, to be positive charge. All right, everyone got this one right for the most part. More protons than electrons. All right, protons and electrons make up the charge in an atom. Protons are positive, electrons are negative. So if you have more protons than electrons, it's going to be negative. I'm sorry, positive. If you have more electrons than protons, that'll be negative. So whichever one you have more of, that's the charge it's going to have. All right. Uranium-235 has an atomic number of 92. All right, the 235 is its mass number, which you talked about. So if it has 92 protons, if you subtract the 235, the minus 92, it would tell you how many neutrons you have as well. However, that's not what the question's asking for. Half of us got this right too. So the atomic number is equal to the number of protons. So if its atomic number is 92, it's going to have 92 protons. All right. So on this periodic table, which element should have similar properties to fluorine? So fluorine is in column 17 right here. So elements that are in the same column are called the same family. This family is called the halogens. They're the most reactive elements on the periodic table. They're very dangerous and they can be poisonous. So any element in the same column is going to behave like other elements in that column. So chlorine and fluorine are in the same column. So chlorine is right below it. So chlorine and fluorine are going to be in the same column. They will have the most similar properties. Neon is next to it, and so is oxygen. Oxygen's very reactive, but not nearly as reactive as fluorine. Neon's not reactive at all, so it's basically the opposite of fluorine. Sodium is on the far other side of the table. So in the same column are the same families. The fluorines are fluorine, chlorine, iodine. Those ones are all in the same category. They're all in the same family of halogens, so they all behave similar. All right, this one we need a lot of help on. 2 kilogram mass is moving at a speed of 3 meters per second. What is the kinetic energy of this mass? All right, so let me move over here. So 2 kilograms at 3 meters per second. All right, and I meant to do this one with just easy math to make it simple for you. Let's see. All right, so kinetic energy is over here. All right, so whatever we're looking for, you cover up. So it says, what is the kinetic energy? So you would cover up this part right here. So it said the mass was 2, and it said the velocity was 3. So make sure you have that right. All right. So when you cover it up, it reveals the equation. So it's going to be 1/2 the mass 2 times the velocity, which is 3. And remember this of the square right here. So it's going to be squared. So if you put this all into a calculator, make sure you put this in parentheses. Otherwise, it'll square your entire answer. So if we do our math here, 1/2 of 2. 1/2 times 2 is 1. So whatever we get for this here is going to be the answer because 1 times anything is itself. So 3 squared is 3 times 3, which is 9. So it turns out to be 1 times 9, and your answer is 9 joules of kinetic energy. So that would be C. All right, number 12, we had some problems with it too. A hydraulic lift uses an automotive repair shop, can lift a 100-kilogram car 2 meters off the ground. What is the potential energy? So if we're doing potential energy now, the question asks you, what is the potential energy? So we cross this out. So it says, now you have mass times gravity times height. The mass was 1,000. Gravity is always, always, always 9.8. And then the height was 2 meters. So there's our information from the problem. So 1,000 times 9.8 times 2. All right, so you might need a calculator for that one. So 1,000 1000 times 9.8 times 2. Now, if you don't have a calculator, you can kind of guess what it is by rounding and getting an estimate. All right, so the real answer was D, 19,600. All right, so if you think about it, all right, let's round this number up to 10. Okay, 9.8 times 10. All right, so that'd be 1,000 times 10 times 2. That comes up to, you could just do 10 times 2 is 20, 20 times 10, or 1,000 is 20,000. All right, and then when you look at the answers you have available, D, let me go back. D here is the closest to 20,000. So even though it's not the perfect answer, it can say, hey, this is the closest to what I estimated. So this is probably the right answer because it's not close to any of these. All right, so don't forget, these two are the ones we struggled on the most. So don't forget your equations and what to do with them. And what I just told you is like a quick way to do the math in your head with even numbers because it's easy to multiply numbers that are multiples of 10. All right, so for these ones, they weighed themselves. Which student had the most power? All right, so power is work divided by time. So which one had, if you divide the student weight, the work divided by the time. So this one is a little bit complicated because you need to do this times this divided by this. So you need to do this weight times the height. Remember, force times distance is work. Work divided by time is power. So it's 440 times 4, that answer divided by 15. And when you do that, student W winds up with the most power out of it. So again, this one's probably the hardest one on there because it involved doing a fair bit of math. All right, but if you're dividing by time, multiplying these two together, divide by time. Okay, last two we did pretty decent on. All right, when a steel block is at 100 degrees Celsius and it's touching a block at 20 degrees Celsius, the heat is flowing by means of conduction. Touching, all right, is the key word. All right, so placed on top of the copper block. So that means that through touching, heat will be transferred. That is by conduction. And half you got that right. Good job. And lastly, a container of cold water is dumped in a large container of hot water. All right, that is mixed and left alone for a period of time. The temperature of the water is found too. All right, so it'll be uniform throughout the container. All right, so if you think about it, what'll happen with that water is it will diffuse throughout the container, kind of like if you leave a cup of ice water out on the kitchen table. If you come back later in the day, everything will be the same temperature as the kitchen air because they'll move towards equilibrium, and it'll the heat energy will equally spread out throughout the container. So it'll be uniform, and uniform just means the same. So it'll be the same throughout the container is another way to word it. All right, and that's it. So obviously you guys got some studying to do tonight, which is fine. So that's all I got for you guys today. A few reminders before we go. Everything is due tomorrow by 5 p.m. Everything is due tomorrow by 5 p.m. It's the last day of class. All right? So please, 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 please do as much work as you can tonight and turn as much as you can in. Some of you guys are in pretty good shape right now because you've just turned everything in. That's basically what I wanted to get across this summer. So turn in the work as much as you can, and you'll be in good shape. If you need help, I'll be available. You can text me or email me or Schoology, message me on Schoology. Um, please make sure it's at normal hours of the day. I got a text at 4 in the morning one time and a Schoology message at 11:45 last night. So I'm obviously sleeping or not working at that time. So if you message me those times, you're probably not going to get an answer until the next day. Okay. So good work today, guys. And you guys are free to go. I'll see you tomorrow.